so synthetic division, we have to have a linear divisor. In long division, we have no restrictions. Now, let's talk about, in general, what things are called. So if we have a division problem, what is x squared plus x plus 5 called? The dividend. What is x minus 2 called? The divisor. Oh, we only got one. Okay? So, we take the dividend, we divide it by the divisor, and we get a quotient. Now, we could potentially have a remainder. What do we do with that remainder? Okay. So, on the next slide, we are going to call the dividend function f, the divisor function d, the quotient function q, and the remainder function r. Okay, we're giving these names. All right, we're taking a polynomial divided by a polynomial, so then we can express things polynomially, okay? So if we take a dividend and we divide it by a divisor, we get a quotient, and then we add on the remainder over the divisor. Okay? Now, if I wanted to rearrange that, like so there aren't any fractions, we can multiply everything by the divisor. So, the division algorithm is that any function, this is what our dividend is, can be written as a divisor times a quotient plus a remainder. Basically, we took that on the front page, we multiplied it by d, and we have this. What this is saying is every function can be written as a divisor times a quotient plus a remainder. That remainder could be 0, but every function can be written like this. Okay, so we're going to practice some long division. And then with our dividend, divisor, quotient, remainder, all of that stuff, we're going to use this to rewrite our function. All right. This is our problem. 2x cubed minus 8x squared plus 3x minus 9, we need to divide by x squared minus 1. It says long division at the top. Why do we have to use long division?
It's not linear.
Our divisor is not linear. This is our divisor right here, not linear. When you put your dividend into your division problem, before you start writing numbers down, what should you look for? Are there any missing terms? Do we skip any powers of x? No, so we can just go ahead and write. If there were any missing terms, you would want to place a 0 there. Our divisor, it has a missing term. So I am okay with you writing x squared plus 0x plus 1. That'll help you keep everything in line. Okay? X squared times what is 2x cubed? 2x. Remember, you need to put everything in the column that it's in common with. Okay. So now we need to take our divisor times 2x. So we get 2x cubed plus 0x squared plus 2x. Okay. Remember from my video that we are subtracting. So I think it would be a good idea for you to just go and change the signs. That way you don't forget. Okay. What are we left with? Once you bring down that constant, you know this is the last time you're going to have to go through the division. Okay? X squared times what is negative 8x squared? Negative 8. So we're going to take negative 8 times our divisor. So negative 8x squared plus 0x minus 8. Remember, we are subtracting, which means we're just going to change the signs. We're going to take that subtraction through. So left over we have x minus 1. Now, what does this mean? We took 2x cubed minus 8x squared plus 3x minus 9, and we divided it by x squared plus 1. Our result was 2x minus 8, and we had a remainder of x minus 1, so we're going to add x minus 1 over our divisor. Okay? If I ask you to simply perform division, this would be your answer. If the instructions were to rewrite your function using the division algorithm, which is what you wrote down from the last slide, you would write it like this. Basically, you're multiplying that x squared plus 1 over. So we can say that 2x cubed minus 8x squared plus 3x minus 9 is the quotient times the divisor plus the remainder. Basically what happens is we can multiply this x squared minus 1 over, and so it gets multiplied to the 2x minus 8, and then it cancels out the denominator here. I am more focused on you being able to do the division, but I am going to warn you that you will have a couple of homework problems that are going to ask you to do this. So perform the division. It would be my suggestion to write it like this. That way you can visualize what's happening. Multiply that divisor over and you have something rewritten. Okay. Any questions there? All right. Next, we're going to talk about the remainder. Does the remainder tell us anything about our function? I want you to think about that with your pod for a few seconds. Does the remainder tell us anything about our function? Like if our remainder was a number, like not x minus 1, that's at least not helpful. If our remainder is just a number, does that tell us anything about our function? Talk about it. All right, anybody come up with an idea? Gabe?
Would it be a transformation?
I don't know. Any other ideas?
You said maybe it's 0.
Maybe it's a 0. Okay, any other ideas? The remainder theorem. The remainder tells us something. If you get a remainder when you divide by a linear divisor, then that remainder is your function value. So Henry, what you said, I want you to keep that in the back of your mind for me, okay? This is the example that we're going to do. Okay, do we have a linear divisor? Yes. Yes, with enthusiasm, right? Which means we can use synthetic division. Do we have any missing terms in our dividend? Okay. If you're confused about what this means, do not panic because I'm going to show you with our example. Okay. If we're dividing by x plus 1, what goes right here? Negative 1. I kind of have to think about that opposite. Okay. All right. Go ahead and perform the synthetic division for me. You do it, and then I'll put my work up here in a little bit. Work together if you need to. Does your work match mine? Drop the 2 down, multiply it by negative 1. Put it under the negative 8, you add the columns. Negative 10 times negative 1 is 10, add the columns to get 7. 7 times negative 1 is negative 7, add the columns to get negative 16. Remember, I like to put a little bar here to separate the remainder from the quotient. Okay? This is what the remainder theorem tells us. If you plug negative 1 into your function, you will get 16. Whatever the remainder is gives you the function value at that number, at k. So since our factor is x minus k, k is what we're evaluating at. Our divisor was x plus 1. So negative 1 was that k value. When we did the division, we got a remainder of negative 16. When you plug negative 1 into your function, you get negative 16. Okay? So, obviously you have calculators that are very helpful. However, if you were at a time where you did not have your calculator, this could be a quicker way of evaluating your function, especially if you have, large numbers that you have to cube or square. Okay. Now, I want you to brainstorm in your pod how this could be helpful besides just helping us come up with a value that could be difficult by hand. Okay? How else could this be helpful? Brainstorm with your group. Henry had a good idea earlier, if you can remember. All right. Ideas. What could be helpful with this? Jackson.
Use it to find zeros.
Oh, if our remainder is 0, is that special? Okay, if our remainder is 0, then we have found a
Zero.
0, and that can help us figure out what's going on the graph. So when we get back from lunch, we're going to look at when our remainder is 0. All right, let's get going here. What I would like you to do is use synthetic division to find f of 1/2 of this function. If I'm asking you to find f of 1/2, that means you're setting up synthetic division. And what goes out here? 1/2. Go for it. You need your function value to be 0. Yeah. That is exciting. Remember, bring down the 2, multiply by 1/2. The 1 goes here. We add to get -14. Multiply by 1/2 to get -7. Add to 20. Multiply by 1/2 to get 10. Add to 0. I like to put a little smiley face in my 0. Getting a 0 is exciting, right? What does it mean? What does it mean if our remainder is 0? First of all, f of 1/2 is 0. Graphically, what's happening there? We have an x-intercept, okay? Or you can call it a 0. We have a 0, okay? And if we know a 0, what else do we know? We know a 0, what else do we know? Jackson? We know a factor. Remember Friday I gave you 0 factors? If 1/2 is a 0, what would be our factor? Okay, which is our next theorem. If we know a 0, then we know a factor. A polynomial has a factor of x minus k if and only if f of k is 0. If you remember back to your geometry days, if and only if means you can read the sentence forwards and backwards and it's correct. If we know x minus k is a factor, then we know k is a 0. If k is a 0, then we know x minus k is a factor. x minus k is a factor if and only if f of k is a 0. So this is what I want you and your pod to talk about. In my example up here, I am asking us to verify that x plus 3 is a factor. I want you and your pod to talk about how we're going to do that. How do we verify something is a factor? 1, 2, 3, go. Oh, are we done talking about fast, huh? Okay, pod 6.
So if it's x plus 3, then you have a negative 3 outside.
Okay, and how will we know if it's a factor?
You would just like x equals 3 to negative 19 and 6, and you would just solve it only if it's 0, then it's a factor.
There we go. If our remainder is 0, then we're going to have a factor. If it's not a factor. This is really why I like to put my smiley faces with my zeros, okay? Bring down the 3, multiply to get negative 9, add to get,
Then there'll be a 2.
where's the 2?
You're at 12.
Oh, well, that'll make a difference, won't it? Not sure why I put,
That's all.
wow. I got really excited when I was trying to talk and write at the same time. Is this better? Don't even know what happened. Can't even come up with how that. All right, so is everyone okay here? Add to get negative 7, multiply to get 21, add to get 2, multiply to get negative 6. Our remainder is 0. Since there is a remainder of 0, when we divide x plus 3 by x plus 3, then we know x plus 3 is a factor. If our divisor divides evenly, it is a factor. If there's a remainder, it is not a factor. Okay? Now, if we know that x minus 3, or if we know that negative 3, what do we call negative 3? A
0.
A 0. Okay, so let's get this vocabulary straightened out. X plus 3 is the divisor. X plus 3 was a factor, which means negative 3 is our 0. Okay? Since x plus 3 is a factor, then we could write x plus 3 times 3x squared minus 7x plus 2. And we can use 3x squared minus 7x plus 2 to help us find the other zeros. Is it possible for us to factor this? Potentially. We know we need 3x and x, right? We need something to multiply to be positive 2, but since this is negative, they should probably both be negative. Our only options are 1 and 2. Where should the 2 go? So it multiplies to the 3x. Okay? So our example really stopped here, right? We verified that we had a factor. Now, if I asked you to use that to find other factors, then we could go to here. Here are our other factors. If I asked you to use the fact that x plus 3 is a factor to find all the zeros, then we could say our zeros are negative 3, 1/3, and 2. Okay? So you can use the fact that we have a factor to help you go further. Okay? Which is something that I am going to ask you to do. You're going to get some questions in your homework that say, hey, verify that this is a factor. Okay, and you'll just stop at the zeros are remainder. Okay. Then you're going to get some questions that say, okay, this is a factor, go ahead and find all the zeros. So you're going to use that factor to break it down so then that you can factor the rest out. Okay. Okay, here's a little review of what we can do with the remainder. Okay, the first thing we can do with the remainder is find a function value. Okay, it is useful, but probably not as useful as the other ones. Okay, if our remainder is 0, then we know x minus k is a factor. And we know that if the remainder is 0, then we have a 0. So we have an x-intercept. Okay? Those three things are three things that we've talked about. I just put them all together on one slide. Okay? So now that we've kind of reviewed everything that we can do, you're going to have to figure out what is going to be useful out of the remainder theorem. So I have one example that I want to go through, and then you'll have time to start your homework. Okay. While you're writing this down, this is giving us some options to find zeros of polynomials that maybe we couldn't on Friday. So on Friday we were just factoring, right? Well, factoring has its limitations. There are some polynomials that are too big for us to factor, but if we know a factor, we can break it down into something that's not manageable. Ready for the last example. I have a 4th degree polynomial that I want the zeros of. And I'm giving you 2 factors. So we know that x minus 5 and x plus 4 should divide evenly into that 4th degree function. Now, if you look at that 4th degree polynomial, we have no way to factor that. There's 5 terms. We don't have any tools to do that. Okay? But since we are given factors, what can we do with those factors? We can divide. Okay? Does anybody have a preference on which one we use first? The first one? Okay, remember to ask yourself, are there any missing terms in our polynomial? No. So 1, -4, -15, 58, -40. Did I do those right? Okay. So let's start with x minus 5. It should be a factor. 1 times 5, add to get 1. 1 times 5, add to get -10. -10 times 5, add to get -8. And -8 times positive 8. 8 times 5 is 40. We add to get 0. If I'm telling you that it's a factor, that should happen. If I tell you that it's a factor and you don't get a remainder of 0, you need to go back and fix your work because you have made a mistake. Okay? All right. Now, we can take our 4th degree polynomial and divide out x plus 4, but that's not going to help us very much. Okay? What we're left with here is x to the 4th. Since we started out with a fourth degree polynomial, we are left with x cubed plus x squared minus 10x plus 8. We started out with a fourth degree polynomial. We divided by a linear divisor, so now we're left with a cubic function. We can try and factor this by grouping, but how's that going to go for us? It's not going to go very well, because here we're going to have x squared times x plus 1, and here we're going to have 5x plus 4. Since those aren't in common, we can't factor by grouping. So what are we going to have to do instead? Keep dividing, okay? But instead of dividing x plus 4 out of the first one, if it's a factor of the fourth degree polynomial, it has to be a factor out of this one. So what I would even do is erase this, and we can use our synthetic division with these numbers. Okay? So now negative 4 is our k value. So 1, negative 4, negative 3, 12, 2, negative 8, all right, 0. Once again, if you don't get 0, you've made a mistake. If I tell you it's a factor, you should get a remainder of 0. So we have done synthetic division twice. We didn't do synthetic division of the x to the fourth degree polynomial both times, okay? We did synthetic division once, and then from there, we did it again. Okay, don't take a step backward. So this is what we have. We have x minus 5 is a factor. X plus 4 is a factor. What degree of polynomial is this? It's a second degree polynomial. X squared minus 3x plus 2. What is x squared minus 3x plus 2 factor to? X minus 2, x minus 1. Those are our factors. If I ask you for all the factors, that would be your answer. I asked you for zeros, so your zeros are 5, negative 4, 2, and 1. If I asked you to graph it, we could plot those zeros. We have a leading coefficient that is positive, so the right is rising. We have an even degree function, so the left is also rising. We could plot our y-intercept, which would be what? Negative 40 is what you'd be left with if you plugged in 0. Probably not going to make it on here. But it would have to look something like that because all of our zeros have multiplicity of 1. Okay. I can't remember if you have to graph on tonight's assignment or not. I'd have to look at it. We can look together. But if you had to do it, we follow the same rules we did from Friday. Okay? So your assignment is this. Your gold sheet will have the bolded problems. I also told you that I would give you an extra practice assignment tonight in case you needed to come talk to me tomorrow about anything. I will give you more details tomorrow about, well, we can kind of talk about your quiz. Your quiz is going to cover the first few sections. So you have putting a quadratic into our new standard form, identifying the vertex, identifying the min or the max. You have Writing polynomials, getting zeros, like we did on Friday. Graphing a polynomial, like you did on your homework this weekend. Finding zeros and commenting on their multiplicity. And then all this stuff with division. Okay? So this blue worksheet just is kind of like a rough extra practice guideline here. You don't have to start on this tonight, but if you're worried about anything that we've done the past few days, you can look at this, and that way you know whether you need some extra help tomorrow. Okay. So we have about 5 minutes left of class. You may begin your homework.